Hey guys, today we are going to talk about the converse of the Pythagorean theorem. So converse, remember, just means we take the if and the then and turn them around. So the converse of the Pythagorean theorem says that if the sum of the squares of the two shorter sides of a triangle is equal to the square of the longer side, then the triangle is a right triangle. So if a squared plus b squared is equal to c squared, then triangle ABC is a right triangle. Okay, so we want to determine whether this is a right triangle. So to find out, we check to see whether 6 squared plus 9 squared is equal to 3 times the square root of 13 squared. Okay? So that would be 36 plus 81 is equal to, and 3 times the square root of 13. This is just one single term because there's not a plus or a minus between these. So I can just square both parts. So 3 squared is 9. The square root of 13 squared is 13. Okay, so 36 plus 81 is 117. And 9 times 13 is also 117. So the answer is yes, this is a right triangle. So this right here would be a right angle. Okay, so we'll do the same for this one. I want to know if this is a right triangle. So I'm going to take the two smaller sides, 16 and 24, and I'll do 16 squared plus 24 squared and see if that is equal to 29 squared. Okay, so I can just type in 16 squared plus 24 squared and save myself a step, and I get 832, and 29 squared is 841. So those are not equal. So no, this is not a right triangle. So there's no right angles in this triangle. Okay, let's try two more of these. So I have 5 squared plus 4 squared compared to 2 times the square root of 10 squared. Okay, so 5 squared plus 4 squared, that's 25 plus 16. And 2 squared is 4 times the square root of 10 squared, which is 10. Okay, so 25 plus 16 is 41. And 4 times 10 is 40, and those are not equal. So no, this is not a right triangle. Okay, so how about this one? 18 squared plus 15 squared equals 3 times the square root of 61 squared. Okay, so 18 squared, that's 324. 15 squared is 225. Okay, 3 squared is 9. 61, square root of 61 is 61. So I've got 324 plus 225. And that is 549. And 9 times 61, try that again, 9 times 61 is 549, and those are equal. So yes, this one is a right triangle, and there's my right angle. Okay, now I know that 2 of these are right triangles and 2 of these are not right triangles. But I'd like to know the ones that are not right triangles, are they acute or obtuse? And there is a way to find out. Okay, so we're going to use this chart here to help us find out. Okay, so if a squared plus b squared is equal to c squared, then the measure of angle C is equal to 90 degrees, and triangle ABC is a right triangle. Okay, but what if a squared plus b squared is not equal to c squared? So if a squared plus b squared is greater than c squared, what that actually does is it forces side C here to be a little bit too short for angle C to be a right angle, which means this is an acute triangle. So angle C is less than 90. So if a squared plus b squared is greater than c squared, then c is less than 90. So we now have an acute triangle. And if a squared plus b squared is less than c squared, okay, that means that c is a bit too long for this angle C to be a right angle. So angle C is actually greater than 90 degrees, which makes the triangle obtuse. So if a squared plus b squared is greater than c squared, we have an acute triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. So here, a squared plus b squared did not equal c squared. It actually happened to be less than c squared. So this triangle is an obtuse triangle. And here, a squared plus b squared turned out to be greater than c squared, which means that this actually is an acute triangle. So now we want to know, can segments with lengths of 2.8 feet, 3.2 feet, and 4.2 feet form a triangle? So that's the first question. And right now I'm not even interested in whether it's an obtuse, acute, or right triangle. I just want to know if they can make a triangle at all. So we've got to think way back to the fact that when I have three lengths, if they can make a triangle, then if I add the two smaller lengths, they have to add up to something greater than the longest side. Okay, now if they don't, then they can't make a triangle at all. Okay, so I'll add up 2.8 plus 3.2, and that is 6. And 6 is greater than 4.2. So this is not the converse of the Pythagorean theorem here. This is just trying to find out if they can make a triangle at all. And because the two smaller sides add up to something greater than the third side, the answer is yes. They can form a triangle. Now, we'll use the converse of the Pythagorean theorem to decide if it's going to be acute, obtuse, or right. So 2.8 squared plus 3.2 squared compared to 4.2 squared. Okay, so 2.8 squared plus 3.2 squared is 18.08, and 4.2 squared is 17.64. 18.08 is greater than 17.64, so a squared plus b squared is greater than c squared. This triangle would be acute. So yes, these lengths can make a triangle. That triangle would be acute. Okay, so now what about 6.1, 9.4, and 11.3? Can those make a triangle at all? 6.1 plus 9.4 compared to 11.3. Okay, so that's 15.5, and that is greater than 11.3. Okay, so the two smaller lengths add up to something greater than the third length, so yes, they can make a triangle. If the answer is no here, I just write no and I'm done. If I got exactly 11.3 or less than 11.3 here, I would say no and I'm done. But because the two shorter sides add up to something greater than the third side, the answer is yes. Now what kind of triangle would it be? 6.1 squared plus 9.4 squared compared to 11.3 squared. 6.1 squared plus 9.4 squared is 125.57. 11.3 squared is 127.69. So a squared plus b squared is less than c squared. This triangle would be obtuse. Okay, so the converse of the Pythagorean theorem has some good real-world applications. One of them is for simply laying a tile floor. How can you use a triangle to help ensure your tiles will fit together correctly? Okay, so this may not be easy to see, but right here, there's a line across this floor, and there's a line this way as well. So the person laying the tile here snapped a chalk line horizontally and vertically across the room. Okay, now we're going to start laying tiles along those lines. Okay, and the tiles will go out this way as well. But if they are to fit together properly, then this absolutely positively must be a right angle. So how can you tell if it's a right angle? Okay, so see the tape measure going here? What you could do is measure, say, 3 feet this way and 4 feet this way. Okay, and if you mark 3 feet and 4 feet, then you can measure across here. And if this is anything other than 5, then you do not have a right angle, because 3 squared plus 4 squared compared to 5 squared, that's 9 plus 16, that's 25. 5 squared is 25. These are equal, which means you would have a right triangle here. Okay, you absolutely positively must have a right triangle. You could use any Pythagorean triple for this. If I measured 5 feet and 12 feet, okay, then I would have to get 13 feet here. Okay, now 3 and 4 are much smaller measurements. It's a lot easier to manage than doing 5 and 12. So the very common way to do this is a 3, 4, 5 triangle. Okay, the same could be done right here. These tiles are laid out. Okay, they're not adhered down yet because they're just being laid out to see if it's going to work. You can measure 3 feet this way, 4 feet this way, and then connect those ends. And you better get exactly 5 feet, and then you know that this is a right angle, so your tiles will fit together properly. Could you use a triangle with side lengths of 50 inches, 120 inches, and 130 inches to verify that you have perpendicular lines? So could I use, instead of 3 feet and 4 feet and 5 feet, could I use 50 inches, 120 inches, and then measure across and get 130 inches? Could I use that? Well, only if those 3 lengths would make a right triangle. So only if 50 squared plus 120 squared happens to be equal to 130 squared. Okay, so let's check that. 50 squared plus 120 squared is 16,900, and 130 squared is also 16,900. So the answer is yes, you could use those, because those 3 lengths would form a right triangle, and a right triangle has perpendicular lines. Okay, so you would have a triangle like this: 50 inches, 120 inches, and 130 inches, and this is a right angle.